How to clean and weigh the helix. Clean the helix as a cathode. Negative current in an alkaline steel electrocleaner at 3 amps for 45 seconds. Water rinse. Immerse the helix in a 20% hydrochloric acid solution for 10 seconds. Then water rinse. And rinse in isopropyl alcohol. Then dry. It is presumed for the purpose of this demonstration that a nickel strike is not required for deposit adhesion. Weigh the helix and record its weight in grams. Then mount the helix to the spiral contractometer.
Get it close to this because I'm putting this under the spiral. Notice that spacing.
Mm-hmm.
We have a magnetic stirrer in the plating bath. We'll begin by plugging the hot plate into a temperature controller. Notice the short length here on the cord. Temperature controller will control the temperature of the bath so that it doesn't exceed the desired plating temperature. Temperature controller long lead will be plugged into the current. The probe for the temperature controller will be placed in the plating solution. Will be brought to temperature. Magnetic stirrer will be turned on. Anode basket. Now this one does not have the anode buttons in, but for the purpose of demonstration, the anode basket will be put in there in a central position. It's designed to be self-centered over the beaker. At this point, we'll plug in the power supply to the clock. And the clock will be plugged into the power source, the main power source. When the bath gets to plating temperature, then we'll be able to calibrate the spiral or the helix. This is a self-centering stand for height and to center the helix in the plating bath. Just sitting that over top of the beaker. It's adjustable to fit any size beaker that holds 4,000 milliliters. Any design of that beaker. Everything is centered. Helix is on the spiral contractometer. Going to mount the spiral contractometer with the contact to my right in the rear. Simply drop this down. You'll note that this has two places that engage holes in the top of the stand to center it. One of the problems with the system prior is that you couldn't get proper centering. It's important to have proper centering and uniform plating around the spiral. Notice that the dial reflects the movement of the spiral underneath. We need to begin by zeroing that dial with the arrow. There's a screw here that we loosen. Now you can see that the spiral is not recording the movement. We'll move the 0 to the arrow. Simply tighten the screw. Now you can see that that movement again is reflected. Normally tap to get the arrow lined with the 0. If you use a finger, the finger motion can influence the reading. So tap with a blunt instrument. If it doesn't quite get the 0, adjust it to the 0. The 0 is lined up with the arrow. I'm placing a loop of a calibration string with weight attached on the pulley wheel, dropping it in a way that it hangs free, but I've gone in a clockwise direction. Now I pick up the other pin, loop it, and wrap around again in a clockwise position. Again dropping near the KC pulley wheel in a way that the weight hangs free. At this point, I use my blunt instrument. I tap to stabilize the tension, and I take a reading. Right now, I'm reading compressive stress, 41 degrees. I'm ready at this point to remove the weights, but I do record that weight because it's a very important weight for the calculations. This time, I take the loop, starting at the arrow, go around to the KT pulley. The T stands for compression, for tensile stress. The C stands for compressive stress. I take the pulley again, the pulley pin, connect the loop to the pulley pin. Come around to the KT pulley wheel. With both weights hanging freely, I do my tapping again. And this time I'm reading 44 tension. I record that value as KT, calibration degrees. Remove the strings, and then check to make sure that I'm coming back to 0. That's not quite at 0, so I would probably, in a real test, redo that and make sure that I have the right numbers. Maybe I didn't tap right or wasn't patient with it. At this point, I'm ready to begin plating. Now at this point, we're ready to begin plating the spiral, or the helix. Of course, the positive lead goes to the anode basket. The negative lead is connected to the spiral contractometer in that manner. I'm ready to set the clock for the plating. 20 minutes, 40 seconds. Turn on the clock, which turns on the rectifier. We plate for 40 seconds. We finished the plating step. At this point, I'm going to tap the top of the spiral contractometer to stabilize the reading. I'm going to take that reading. I'm getting a reading of 24 tension degrees. That will be recorded because we'll need that number to calculate the deposit stress. I'm going to remove the spiral contractometer with the helix plated at this point. Go through a water rinse. There are drain holes designed in this center piece that allows free rinsing of the helix. I'll go into the isopropyl alcohol. Again, giving it a thorough rinse. Next step is to remove the helix from the spiral contractometer. Simply lay it on its side in a way that the screws can be loosened. The spiral contractometer is removed from the helix is removed from the spiral contractometer, I should say, dried, and then weighed to determine the weight of the deposit, which will be used in calculating the deposit stress. You'll notice I'm using surgical gloves to prevent getting any oil or contamination that would affect the final weight. It helps to hasten the drying by doing what I'm doing at this point, just rolling a paper towel through the spiral or helix, drying the outside. When you weigh it, make sure that the weight isn't changing. If there's moisture there that's on the helix and it's disappearing, the weight will be dropping. So wait until there's no decrease in the weight value. That's the finished plated spiral.